guys, it's Mrs. Hedrick. Hey, listen, so this is our first video math lesson. This is for Math 8. So we're going to give this a try. Today I'm going to go over some notes and we're going to work in our instruction book. So you're going to need, if you brought your math spiral home, if not, you're welcome to use notebook paper. If you have some fun colored pens or pencils, and you're definitely going to need a pencil for your instruction book. Instruction book also needed. So pause me here, run and get your supplies, and come back and we'll get started. Okay, so I'm coming to you from the basement of my house. This is usually where Mr. Hedrick does his workouts. This is his dry erase board that he salvaged from the trash at work. And so I've kind of commandeered it. So this will be our classroom for a little while. So we're going to give these a try. I'm going to kind of teach it like I would in class. We're going to do some notes and we're going to work in our book. Okay? All right, so grab some fun colors. Let's start with our notes. So we're in lesson 18, and lesson 18 is on transformations. I believe the full title is Understand Properties of Transformations, and this is an understand lesson. So that means that this information is new to you. We didn't talk about this last year. This is brand new to you in 8th grade. They will also continue to talk about it next year. I suppose the algebra kids may have already done some of this. Now, for my algebra students, you're welcome to take the notes with us. You're welcome to watch the video. You won't have the books in front of you. So you never did have to do the lessons. You just had to take the quizzes. So take the notes, at least. Have those with you. You're welcome to watch through the video if you would like. I ask that everybody complete that iReady lesson. That's the lesson that matches the lesson that we're doing now. So if you pass that with a 75% or higher, you got an M on that. If you passed it at 74 or below, I had several students at a 70%. Go back and do it again until you get above 75. Some of you took it the first time and did really, really well, so I appreciate that. Good job. Okay, so for my algebra kids, between these notes and that lesson on iReady, you should be fine for the quiz. The rest of us, we're going to do some practice in the book, okay? Notes for everybody. All right, let's get started. So in your notebook or on your paper, this is lesson 18, and these are transformations. Okay, so if you think about the word transformation, I hear the word transform. So transform is to change, right? These transformations are pretty simple. We're talking about how do you transform a geometric shape or a picture even. So what are the things that you can do? The transformations that we're going to start with are in your book on page 160 and 161. We're going to start with 3 of them right now. Okay. So first of all, what is a transformation? Let's do the definition. Transformations are when you move a figure from one place to another. Easy enough. When you move a figure from one place to another, the figure keeps the same shape and the same size. They're congruent. I'm just going to use this heading. So transformations are when you move a figure from one place to another, okay? The figures keep their same shape and same size. And something that has the same shape and same size, congruent. These are congruent. Now, the 3 transformations we're going to be talking about now are when the shapes stay congruent. There are other ways to change a shape that are not congruent, and we'll talk about those later. But right now, these three are the same. Okay, so transformations are when you move a figure from one place to another, when you keep the same size and you keep the same shape, they're congruent. So you're going to skip a line and keep going through definitions. I'm going to erase this to give myself some more space. The first one I want to talk about, oh, and if I'm going too fast or like you didn't get that, pause. That's the beauty of this. You can pause it, you can rewind it, however you'd like to do it. Watch it over and over again. There aren't any children talking to interrupt our lesson. Now, the bad part is you can't ask questions, but we're going to do our best, right? Okay. All right, let's start with translation. Again, these definitions are in your book if you want to check spelling or check the definitions 160, 161. Okay, a translation is when you slide a shape. So you can slide it to the right, slide it to the left, you can slide it up, you can slide it down diagonally. Okay, so a translation is when you slide a shape. So you can go up, you can go down, you can slide it to the right, you can slide it to the left. You can combine up, down, left, and right. That would give you like a diagonal, right? If you went up and right, the shape would go that way. If you go down and left, the shape would go diagonally that way. Now, here's how I remember which shape is what, or what transformation is what. Okay, so if you notice there's an SL in this word, translation. There's an SL in slide. So translate is a slide. So you're going to slide the shape from one place to another. Just that simple. Translation is a slide. Okay? Let's go on to our next one. Oh, let's draw a picture. Oh, you know me, I like examples. Let's pick a color. How about blue? So I'm going to draw a little triangle. Here's my little triangle. I'm going to translate it up and right. So it's going to end up going this way. Okay, I tried to draw an equilateral triangle. So same size, same shape. It's just, imagine if I put my fingers on this, I could slide it anywhere on this board. Okay, that's a translation. Okay. Let's go to reflection. Now, if I think of reflection, I automatically think of the mirror. So when I look in the mirror, I see my reflection, right? Or in a piece of glass, or if you look into water, like a lake or something, you might see your reflection. All right, a reflection is when you flip a shape over a line of reflection, or a line of symmetry, I believe. Okay, so we're going to flip a shape over a line of reflection. Okay, can you see the secret letters in this word? So for reflection, there are the letters FL. And in the word flip. So a reflection is a flip. I like to think of a reflection as like when you make pancakes. Okay, so let's say you had pancakes for breakfast. When you have your pancake in the skillet, you put your spatula underneath it and then you flip it over. Now you probably flipped it back to the same spot, but let's say you had a big griddle and you could put your spatula under it and flip it over to someplace else. That's what a reflection looks like. So let's draw a picture. For my pictures, I'm going to draw an axis, an X and Y axis. So I'm going to draw one here, and then I'm going to do another example over here. Okay, and I'm going to label X, right? X axis, Y axis, X axis, Y axis. You guys know this is old school. Okay. All right, so let's do, I'll stick with the red. Let's say I have a triangle over here. I'm going to draw a right triangle. You need to draw this too. Draw these with me. Okay, there's my right triangle. Okay, I want to flip this. I want to flip it across the Y axis. So here's the Y axis. So I'm going to take my spatula, right, my pancake. I'm going to slip it underneath this shape, and then I'm going to flip it over. Okay, and I'm flipping it over the Y axis. So I'm going to jump over the Y axis. Now, couple important things. So this is going to be a mirror reflection. So it's going to look like this. Oh, please pretend these look alike. Okay, okay, pretend. It's a little bigger. Okay, couple of things to remember. The distance between this point and the y-axis is the same distance between this point and the y-axis. The distance between this point and the y-axis is the same as the distance from the y-axis to this point. So they're equally spaced on either side of the y-axis. So if you want to write yourself a note, this one has been reflected, if I can spell, reflected across the y-axis. Okay, so I flipped it over. That's a reflection across the y-axis. Okay, now let's do one where we reflect over the x-axis. Let's draw the same shape. Try to keep it in the same spot. Okay, so here's, mine didn't do very well. Okay, pretend. Okay. All right, this time I want to reflect it over the x-axis. So I'm going to put my spatula underneath this, but I'm going to flip it down now, right? So put my spatula underneath it and I'm going to flip it. So it's going to be a mirror reflection of how it looks now, but on the other side of the x-axis. So it's going to be upside down. And there it is. So if I take my spatula, I put it under my triangle, and I'm going to flip it over. And I have, this is a reflection across the x-axis. So I'm going to write myself a note that this is reflected across x-axis. Okay, now they can do some crazy things too, like we can reflect these across different lines of reflection. The most common lines of reflection are going to be the x-axis and the y-axis. Not the only ones, but those are the most common, okay? So a reflection is a flip. So far, so good? Okay. Last one of these that I want to talk about is a rotation. I'm going to erase, you skip a line and keep going. Okay, so let's talk about a rotation. Hopefully that one sounds pretty clear. Rotation, to rotate something. So if I stand here and I rotate 90 degrees, what am I doing? Another 90 degrees, another 90 degrees, another 90. So I'm rotating, what am I doing? I'm turning, right? So a rotation is to turn or rotate a shape around a fixed point, a center of rotation. So, okay, it's kind of crazy. Let's go with the easy part. To turn or rotate a shape. Okay, let's start there. To turn or rotate a shape now I'll add the extra part here. Around a fixed point. Okay, and that's called the center of rotation. I don't know how much experience you have with ice skating. Maybe you've seen it, maybe you haven't. I'm talking about like figure skating on like the Olympics. So if you've ever seen the girls and the guys when they do those spins, and they spin right in place, right? So if you think about their center of rotation, it's going to be right down between their feet or right above their head. They're going to spin around an axis, kind of like the Earth spins on its axis. The center of rotation is going to be in the center. Okay, now let's say there's two people, there's a couple, right? And let's say the guy has a hold of the girl. Have you seen those where they spin, like he'll put his skate down and then she'll spin, they'll spin in circles, like he has her kind of stretched out and he holds her by the hands. Okay, now she's spinning, but the center of rotation is far from her body, right? It's not near her. So the center of rotation is kind of like, where do you put your finger to slide it, to turn it around? Okay, so let's see if we can draw a picture. Okay, we don't really need an X and Y axis on this, I don't think. Okay, so let's draw, I've been drawing those triangles, right? So let's stick with the right triangle. Okay, Let's say I want to rotate this. I have a couple of options. If I make my center of rotation here, imagine I put my finger here. Pretend this is I should have cut out a piece of paper. Let's pretend this is a piece of paper and I want to spin it. That would be my center of rotation. Hey, here are your notes. I'll leave your notes up here. If I put my finger there, I can rotate this rectangle. There you go. The center of rotation is in the center. I can rotate it again. I can rotate it again. Same thing here. I could rotate this around the center of rotation. What if I want to move the center of rotation? Let's say I want the center of rotation to be here. So if this were a piece of paper, I'd put my finger here, and then I could slide my triangle. Let's say I do that. Maybe I want to rotate it 90 degrees. So now it's going to look like that. Oh, if I keep going, it'll kind of look like a pinwheel, won't it? Okay, so this is a rotation. This is a 90-degree rotation. Do you know which way I'm moving? I'm moving to the right. Is this clockwise or counterclockwise? Which way would that be? Think of the second hands on a clock. So this is clockwise. So I just rotated this triangle 90 degrees, right? From this point to this point is 90 degrees clockwise. And the center of rotation is here. Okay, this one, this isn't hard, I don't think, the turn. The hard part is where's the center of rotation. So sometimes you have to stop and think about that. Okay, okay. I would probably include that picture. Okay, all right. I am done with notes. So my algebra kids, you're welcome to stay on and watch what we're doing in the lesson, but you won't have the book in front of you, and I can't project it up on my screen, obviously. So you're welcome to go. Just make sure that you did the iReady lesson on, what was it called? Properties of translations and reflections. Make sure you got 75% or higher. If you didn't, go back and do it. I think you can repeat it multiple times. Okay. All right. Okay, my friends, you are now going to join me. So grab your pencil and your instruction book, and you and I are going to look on page 162 and 163. Okay, 162, 163. Okay. Okay, I've got my teacher's edition. I'm going to read from the book. I really would like you to read along in your book. You have a couple of options. You can write the answers in as we go, which probably is a good idea so that you can use this when you take your quiz. You can also use the notes that we just wrote when you take your quiz. I'm still trying to figure out how I'm going to do that quiz. I'm working on it because it's not digital, so I can't take that quiz and put it in and have you interact with it. So I'm working on it. Okay. All right, my friends. I'm on page 162. Let's go ahead and read through these. The blue figure, yes, the blue figure is a transformation of the red figure. So the red figure was original. The blue is what they did to it. Okay. Red is original. Number 2 says, in the transformation, a translation, a reflection, or excuse me, is the transformation a translation, a reflection, or a rotation? Explain your reasoning. How do you think they got from the red shape to the blue shape? What do you think? Let's go with the easy one. Is it a slide? So imagine putting your finger on top of the red shape. Can you slide it to make it look like the blue one? So can I slide it down to the left? Is that going to work? I don't think a slide's going to work on this. Okay, so I think our slide is probably out. All right, let's stop and think about a reflection. So get your spatula out, put it under the red shape, and flip it over. If I flip it over the y-axis, no. What if I flip it over the x-axis? Now that's interesting. If I flip that over the x-axis, it might look similar to the blue, but the problem is when you reflect, you can't. That would also be a translation. So that's not going to work all by itself. It's not a reflection by itself. So if I use my deductive reasoning skills, it's not a translation. It's not solely a reflection. So it must be a rotation. Okay. So number 2 is a rotation. All right, now I told you this was the hard part. Where do you think the center of rotation is? If we had tracing paper, if we were at school, I would get the tracing paper out and we would lay it on top and we would trace the red shape. So if you have tracing paper, stop, pause me, run and get it, lay a little piece on top, trace the red shape. Figure out how you rotate that. Where would you put your pencil point to twist that so that it turns into the blue shape? Any guesses? If you figured it out, this is a rotation. They turn the figure 180 degrees around the origin. Do you remember what the origin is? The origin is 0, 0. So if you take your pencil and put it at 0, 0, if that were on a piece of tracing paper, and you rotated that shape 180 degrees, that would be counterclockwise. That would be back. Well, I think you could go both ways since it's 180 degrees. Either way, clockwise or counterclockwise, you're going to get this shape. So it is a rotation 180 degrees around the 180 degrees around the origin. Okay, that's a pretty common point of rotation. All right, let's go to number 3. How do the lengths of all the line segments in the original figure compare to the lengths of the line segments in its image? How do you know? Okay, so this is important. One of the things to remember about this lesson is none of our shapes are going to change size. All sides stay the same length, all angles stay the same measure. So our answer to this is that they're the same. Same lengths. How could you check? You can count, right? You can count across the grid paper to see. Okay, let's go to number 4. Describe the angles of the original figure. Describe the angles in the original figure. Describe the angles in the image, in its after image, after you translate it. They're the same, right? So we could say for number 4, the angles are the same size, and the length of the lines are also the same. So same size, same shape. Number 5, are any of the line segments of the original figure parallel? What do you think? Are any of the lines in the original figure parallel? Are any of the line segments parallel? Well, if you're comparing the two shapes to each other, they have sets that are parallel. In the actual image, they're intersecting, right? In the red image, the lines intersect. Now, what's interesting is, oh, I see it. Do you see it? There are a set that are parallel across the top of the shape and down along the x-axis. So there are a set that are parallel. They're hiding in there. I see them. Okay, now let's give it a try. Number 6, try this problem. Okay, use a separate sheet of paper to trace the red figure shown. See, we need our tracing paper. You could use Xerox paper, or honestly, some of your notebook paper is like really, really thin. So go find a piece, pause me, run and get a piece of paper. Okay, you're going to lay it on top of this design, and you're going to trace the red figure. Okay, it says cut out the figure and use the cutout to decide how you could move the red figure to get to each of the blue figures. And then write the letter of the figure that matches the transformation, and then complete the problem. Okay, so stop me here and go ahead and trace that shape, cut it out, and move it around. How do you get to A? How do you get to B? How do you get to C? I'll give you a hint. One is probably, yes, one is a translation, one is a reflection, one is a rotation, okay? So I'm going to keep talking with the answers. You feel free to pause me and figure it out. Okay, all right, for number 6. Okay, what do we know? Translation. Which one is a translation from the red? It almost looks like a boot, doesn't it? Like a boot turned sideways. Okay, how do you get to C, from the red shape to C? That is a translation. So the first one is a translation. Describe the move. Each point is 3 units to the right and 3 units down. 3 units right, 3 units down. Now, What if you said, oh, I did 3 units down and then 3 units right? Same thing, order doesn't matter, you'll get to the same spot, okay? So to go from the red shape to C, that's a translation. Okay, which one do you think is the reflection? So imagine your spatula, put your spatula under the red shape and flip it. Which one is it? A, hopefully you saw that. So A is the reflection, okay? And then draw the line of reflection. So take your pencil on your book and just kind of draw that line. It's going to be 1 unit away from the ends, right? Right down the middle. Okay. And then, so that must be the rotation is B. All right, and draw the point that is the center of rotation. So this is hard. There are no axes on here. There's no x-axis, there's no y-axis. Can you figure it out? If you go diagonally from the bottom left of that red shape and put a point there, that's the center of rotation. So if this is the little, sorry, I keep calling it a boot. It looks like a little boot. And this is the, these are my grids, and pretend. This is the center of rotation. So if you could have this on tracing paper, put your finger there, you would rotate it, and so it would come down here, right? This is the reflection. Excuse me, the rotation. Okay. All right, let's keep going. Next page. Number 7. Look at your answers to problems 3 through 5 on the previous page. What properties of the figure's lines and angles remain the same when you rotate the figure? So what stays the same in a rotation? Go ahead, say it out loud. What stays the same? Right, same side, the lengths of the sides are the same, and the measure of the angles are the same. Same, they're congruent. So the length of the sides are the same, the angles have the same measure. Okay, let's go to number 8. Number 8 says, trace the red figure at the top of the previous page. Cut out the figure, use the cutout and a separate sheet of paper to create a translation and a reflection of the figure. What properties of the figure's lines and angles remain the same when you translate or reflect the figure? Well, I'm going to save you some work. You're welcome to do that. But you don't need to, right? We talked about this right at the beginning with our definitions. For these transformations, translation, rotation, reflection, what do I know about the shape? It stays the same size. So that's what they want you to know. That's what they're trying to teach you. Lengths of the sides stay the same. Measure of the angles stay the same, congruent. We're not changing the shape or the size of the figures. Okay, try it another way. You ready? Work with your group to explore the properties of rotation using rulers and protractors. Okay, I miss you guys. All right, so it looks like you and I are partners. You're going to need a ruler and a protractor. I don't know if you have those at home. You probably have a ruler. I don't know about the protractor. So pause me, scour the house, and see if you can find a protractor. Okay, I'm going to keep going. Okay, number 9 says, measure the lengths of the sides of triangle ABC to the nearest centimeter, and measure the angles to the nearest degree. Okay, so this is the, what is that, pink? Pink, kind of, yeah, looks like pink. Okay, all right. So number 9. Okay, so segment AB, what did you get? 5 centimeters. Segment BC, 4 centimeters. And segment AC, what did you get? 3 centimeters. Okay, now the angles. Let's see how you did. Okay, angle A. So and it might take you a minute to remember how to use your protractor, right? The point A goes in the center, that little dot on the inside of your protractor. Line up the bottom on AC, and then you can read the angle. Now, remember that this is going to be an acute angle. So when you measure your angle, remember there's 2 numbers that are showing. This one is acute, so pick the smaller one. All right, angle A. Wow. Okay, let's see how precise you are. 53 degrees. okay? Angle ABC. So take your finger, A, B, C. Okay, that's the one where it touches. Really, they could have written angle B, but that's okay. 37 degrees. And then angle C, 90 degrees. Oh, sorry, it's like a 6. Okay, is 90 degrees. Now, I can double check these, right? Do you remember the sum of the angles in a triangle is 180? So if I add these three numbers together, they should equal 180. I think we're good. All right, now number 10 wants you to measure the lengths and the sides of triangle XBY to the nearest centimeter and measure the angles to the nearest degree. You know what they want you to see, right? They want you to see that the angles are the same measure and the segments have the same measure, right? Just because you rotated it doesn't mean that it changes size. So let's go ahead and check it. So segment XB is congruent to segment AB, so this is 5 centimeters. Segment BY is congruent to segment BC, that's 4 centimeters. And segment YX is congruent to segment AC, this is 3 centimeters. Angle X congruent to angle A, 53 degrees. Angle XBY congruent to angle ABC, 37 degrees. Angle Y congruent to angle C, 90 degrees. Okay, so they really wanted you to measure with a ruler, with a protractor. If you didn't have one, it's okay. The moral of this question is, in these transformations, they do not change size or shape, okay? Which is probably, number 11 says compare the triangles. What can you say about the length of the sides and the measure of the angles? Go ahead and say it to me. Write it if you want, or just say it out loud. What do I know about the length of the sides? Same. What do I know about the measure of the angles? Same. Okay, so not too bad. All right, my friends. So it won't be this long every time. We had some notes. I'm going to be posting the answers to homework. I'm just going to post the pictures from the teacher's edition on homework. So I won't ever be going over homework unless somebody gets on the stream in Google Classroom and says, I really don't understand how you did number 5 on the homework, then I can go over it. But other than that, I'm going to put the answers to homework. Homework is practice, right? I've never graded it. It's always been for practice. So try it. And then you can check your answers. So speaking of homework, tonight I'd like you to work on practice and problem solving 195 and 196. Okay? All right, well, we'll see how it goes. I think towards the end of the week when we do the guided and independent practice, I'm actually going to try to film this differently. I'm going to copy those pages and write on the paper. So we're going to do a different setup. We'll see how it goes. Okay, I love you guys. I miss you guys so much. So hang in there. We got this, okay? Bye.